This example is for a Wronskian with three functions. So we have w of y1, y2, y3. We want to know where does the Wronskian and the theorem guarantee that those three functions are linearly independent. Those functions are x and 1 and 3x minus 2. So if we calculate the Wronskian, so that'll be x, 1, 3x minus 2 equals determinant of, okay, so I have x, 1, 3x minus 2, derivative of x is 1, derivative of 1 is 0, derivative of 1 is 0, derivative of 0 is 0, derivative of 3x minus 2 is 3, derivative of 3 is 0. So we actually already know, because the determinant, right, we have a row of zeros here, the determinant is going to be 0. But if we went through and actually calculated it, it's going to be x times 0 plus 1 times 3 times 0 plus 3x minus 2 times 1 times 0 minus x times 3 times 0 and minus 1 times 1 times 0 minus 3x minus 2 times 0 times 0. Every single term has a 0 in it. So the whole thing actually ends up being 0. And so, the theorem doesn't say anything. All right, so then we should look a little closer and see if these are linearly independent or linearly dependent. And I just made this one up to be a nice example, but it's fairly straightforward. So in here, I have a function is linearly dependent if I can construct it from the other remaining functions. And I definitely can. So y3 is equal to 3x minus 2. That's the same thing as 3 times y1 minus 2 times y2. So y3 is it's a linearly dependent function for the functions y1 and y2. So these three functions are linearly dependent.